In this unit, we're talking about radicals. And you know of square roots and cube roots, and we're going to be looking at a lot of different roots. But to be able to simplify radicals and work with them, we need to remember some of our perfect squares, perfect cubes, that type of thing. So we're going to start just with our perfect squares. 1 squared is 1. 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, then we'd have 100, 121, and so forth, ... Perfect cubes. That's when you're multiplying something by itself 3 times. So 1 times 1 times 1. 2 times 2 times 2. 3 times 3 times 3. And so forth. And I'm trying to line them up with their base. 3, 4, 5, 6, 7, 8, 9, 10. So 5 cubed is 125. 6 cubed would be 216. 7 cubed is 343. 8 cubed is 512. 9 cubed is 729. And 10 cubed is 1000. This will help us that we can reflect back on these. So that's why I'm filling this in for you. 1 to the 4th power will be 1. 2 to the 4th power is 16. And if you notice, 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So that's another way that you can fill in this table. 4 times 4 is 16. 16 times 4 is 64. 64 times 4 is 256. And then this would be 625. And then 1296. And then this is 2401. And this is 4096. Nine to the 4th is 6561, and then we'd have 10,000. ... Now let's look at parts of a radical. So a radical, this symbol right here with a little hook and then the flat part is called the radical sign. What's underneath is called the radicand. The symbol out here, or the number out there, is called an index. And it determines the type of root. So that number decides the root, whether it's a square root, a cube root, a 4th root, a 5th root. Now normally, you don't see a number there. And that's usually when we have a square root. So if we see no index there, that means we're looking at the number 2. So a square root. Now thinking about what it means, a square root means what times itself, what times what, gives me that number. So we filled in some of them. 16 is 4 squared. Now technically, when we take the square root of a number, we could have positive or negative answers, right? And we'll kind of go over that. But if we think about what squared gives me 16, there'd be a positive or a negative 4. We'll talk about this in a second. 121. Well, that could be 11 or negative 11. 289 would be 17. The square root of a fraction, what times itself gives me 4? Well, that's 2, and then that's 5, and technically there's a little plus or minus there. What times itself 3 times gives me an 8? Well, 2 cubed gave me an 8, so that's 2. Now, could it have been a negative 2? No, because negative 2, a negative times a negative is positive, and if I multiply by another negative, I'd get a negative answer. What about 343? Well, that was 7 cubed. Here's a negative cube root. So that means it had to have been a negative number to start with. 5 cubed is 125, so this would have had to have been a negative 5. The cube root of a negative number is going to be negative. And the cube root of 1 is 1, and the cube root of 27 is 3. Fourth roots, so that's this row. The fourth root of 1 is 1. The fourth root of 2401 is 7. Oh, technically, couldn't it have been a positive or a negative? Because if I multiply negative 4 times, I'd get a positive answer. Same thing here. 4096 could be a positive or a negative 8. And here to get an 81, that's a 3. And to get a 16, that's 2 to the 4th. So if we have an even index, and the number underneath is positive, we will get a real answer. And technically there's 2 roots, positive and a negative. If we have an odd index, 3rd root, 5th root, 7th root, and there's a positive number underneath, first off we get a real answer, and we get 1 positive. If the number underneath is negative, we get a real answer, and it's 1 negative. If we have an even index, and the number underneath is negative, we do not get a real answer. We actually get an imaginary. Now, because it's even, that means we could have 2 possible roots, a positive or a negative root. But when we're simplifying, we are always going to simplify with what is called the principal root or the positive root. So when we're asked to simplify radicals, number 1, we're always going to have a positive answer. Number 2, we're looking for perfect squares, perfect cubes, that type of thing. So in this video, I'm going to show you a way to simplify these, even if you have trouble working with radicals. So for this, you might want a calculator. So 117, that's not on my list. It is not a perfect square. So what I'm going to do is break down 117. In other words, do you remember those tree diagrams you made where you figure out what multiplies together to give you that number? That's what we're going to do. So 117, it's an odd number, so I'm not going to start with 2. I'm going to start with 3. 117 divided by 3 gives me 39. 39 looks like it's divisible by 3, and it is. It gives me 13. Now 13 is a prime number. It doesn't break down anymore. So I end up with 3 times 3 times 13 is another way to write the square root of 117. But this pair of 3's really could be written as 3 squared. 3 times 3 is 3 squared. So when I see this pair and my index is 2, okay, so there was no index written, so that's an index of 2, I'm looking for a pair, a perfect square. Any pairs are a perfect square. The square root of 3, the square root of 3 times 3 is just a 3. The 13 was not a perfect square, so it has to stay under. Because this really means I'd have the square root of 3 times 3, which is 9, times the square root of 13, and the square root of 9 is 3. So anytime you see a pair, you can take out the root as a single number. The square root of 9 is 3. Let's try this one. 320. Okay. So first off, I think that would be 32 times 10. And 10 would be 2 and 5. This would be 2 and 16. 4 and 4. 2 and 2. 2 and 2. Ooh, I like this. I see a lot of pairs. Not pairs like fruit, but pairs of numbers. So if I look at this, I have a 2, 2, 2, 2, 2, 2. I got 6 of them. 2 times 2 times 2. 2 times a 5. Every pair is a perfect square. So I have a 2 that gets to come out, another 2 that gets to come out, and another 2 that gets to come out. That's a total of 8 that gets to come out. 2 times 4 times 2 times 2 times 2 would be 8. So this 4 that's on the outside is going to get multiplied by the 8 that gets to come out, and that leaves me with 32 square root of 5. Now what would be different if I'm simplifying a cube root? Well, if it's a cube root, I'm not looking for pairs. I'm going to be looking for triplets, 3 of a kind, because it says 3 there in the index. So I'm going to break down 48. 48 is, I'll just go easy. 2 times 24, 2 times 12, 2 times 6, and 2 times 3. Now I could list them all out like I did here, and I will, but you can also start to see that triplet right there, the 3 2s, 3 of a kind. So when we get in a little bit further, I may just be circling the 3 of a kind where I see it. Now be careful, there were 4 2s, but we only want 3 of a kind. The root gets to come out, so a single 2 gets to come out, and it's going to multiply with the number in front. And then underneath I have a 2 times a 3, which is a 6. So 4 is going to be on the outside, cube root of 6. Try this one on your own if you want. 108. You should have gotten that 108 breaks down to 2, 2, 3, 3, 3. Group of 3s. So a 3 gets to come out. It's going to multiply with that 3 and give me a 9. Cube root of 4. Cube root of a negative is going to end up being negative. So I know my answer is going to be a negative. You see what I did there? 3 of a kind gets to come out as a single root. The 2 did not have partners, so he's had to stay under. I couldn't break down 2. What am I looking for on number 7? The index is a 4, so I'm going to be looking for 4 of a kind. And as the 3 gets to come out, the 2 has to stay under. Oh, I forgot to box all my answers. Slacking. And if you're wondering what I'm doing, I'm actually using a calculator. I'm taking each of those numbers and I'm dividing by 2 because it looks like they're all divisible by 2. I have 4 of a kind there and 4 of a kind here. So each of those as a single root gets to come out. So the 2 and the 3 get to come out. There's a 2 left in, and that's 30 fourth roots of 2. Now what am I going to do about variables underneath? Same thing. So in square roots, we're going to look for multiples, exponents that are multiples of 2, because that would be a pair. Cube roots, we're looking for multiples of 3, because that would be 3 of a kind. And fourth roots, we're looking for multiples of 4. Same principle. Because technically, x to the 4th is x times x times x times x. It's 4 of them. So I'd have 2 pairs. So, 32, I'm going to break that down. 32, 2 times 16, 2 times 8, 2 times 4, 2 times 2. Looking for pairs. This is a square root, pairs. So a 2 and another 2 get to come out. So I'm going to have a 4 out here and a 2 left under. Now, I'm going to talk about the variables now. And I'm doing this first one really long. X to the 4th would be x times x times x times x. And y to the 9th would be 9 of them in a row. 7, 8, 9. We're looking for pairs. I have a pair of x's. I have a pair of x's. So an x and an x get to come out. So when I take out an x and an x, x times x is x squared. Out of the y's, I get a y, 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 y. I'm not complaining. I'm just talking about y. So that's y to the 4th. Gets to come out. What is left under that hasn't been paired up? Well, there's a 2 and a y. Now, one way I could do this, another way I could do this is x to the 4th. If I divide that by 2, I get x squared. Y to the 9th. If I divide by 2, I'd get a 4 with a remainder of 1. 4 times 2 is 8, and 1 remainder. 324. 324 is 2 times 162, 2 times 81. Hey, I'm going to do something interesting here. I know 81 is 9 times 9. That's a pair. I don't need to keep breaking it down. I already found a pair. Cool. Actually, both of those were pairs. So I'm going to get to pull out a 2 and a 9 and have no numbers left in. Coolness. That's an 18. Now let's think about what this would be written out. I'm going to do this one the full-on way again. That's 7 of them. A cubed. There's a pair of A's, but one has to stay in. B to the 7th. I'd have 3 pairs, B to the 6th, and one has to stay in. So I'd have 18, 1A comes out. B times B times B is B cubed, and an A and a B stay under. $216. 108, 254, 2 and 27, 3 and 9, 3 and 3. I have, is that right? That's a 6 that gets to come out because I'm looking for triplets. That's an index of a 3. So a 6 gets to come out. M cubed means there's 3 M's. This would be 6 N's, so that'd be 2 sets. Oh, that's really simple. Okay, what about 56? 56 is divisible by 2. Let's see, that's 2 and 14, 2 and 7. Pair, 3 of a kind. Index is 3, so I'm looking for 3 of a kind. Now, maybe we can break down r to the 8th with not having to write so many of those. How many sets of 3s would I have? I'd have 2 sets of 3s. Okay. A 7 was left as a number. Let's get back to this. I'm sorry. 3 of a kind of 2s, 7's left under. R to the 8th, that would be 6 R's, which is 2 sets of 3s, and then there'd be 2 R's remaining. S would be 4 S's in a row. There'd be 1 set of 3 and 1 left in. Notice this one's negative. That means my answer is going to be negative. Two sets of 3s, 3 of a kind. So 2 and another 2 come out, and that's a 4. No other numbers are left inside. So think about x to the 10th. So I'm picturing it in my head. That'd be 9 x's in a row and 1 left. For the y's, if I have 21 of them, that's 7 sets of 3s, because 7 times 3 is 21. It's going to be a negative answer. set of 3. Three left in. P squared, that's just a pair. I need a 3 of a kind, so he stays in. Q the 12th. Ooh, 12 divided by 3 would be 4 evenly, so I have Q to the 4th coming out. Fourth root, I'm looking for sets of 4. So W to the 4th would give me a W. If I divide 17 by 4, I'd have 4 with a remainder of 1. 4 times 4 is 16, remainder of 1. So the remainder, 1V, stays in. Fourth root of 48. Two comes out, 3 is the remainder, he stays in. M to the 8th, that's 2 sets of 4. 8 divided by 4 is 2. N cubed, it's not a set of 4, it's not divisible by 4, so it stays under. Four of a kind. 23 divisible by 4. It's going to be 5 sets with 3 left in. D to the 11th divided by 4. 4 times 2 is 8. And then 11 minus 8 is 3, so there's 3 left in. Ooh, exponent there is an 8. Divided by 4 would be a 2. Now this could also be written a different way. We could simplify this. I could distribute. And now on to the practice problems. If you run into any issues, come in and get help.